Hey everyone, good evening, guys. Good evening, all. Good evening, everyone. I'm good, and hoping everyone is doing really great and fine, happy and healthy. Let me quickly share my screen, guys, and yeah, here we go. Awesome. The screen is visible, voice is good, everyone. Good to start. Awesome. So we were doing this pandas, and we finished the I think pivot was no, yeah, pivot. We did pivot, right? Let me quickly scroll what we have today so that I can mention what we will be doing. Merge, concat, missing values, outliers. Perfect. So for today's agenda is we will be able to finish this entire pandas and there will be few new concepts as well. After the pivots, we have some statistical functions. So first we will be doing some statistical function to thick. Let me, yeah. First we'll be doing some statistical function. Second, we have merge and concatenate. Basically, merge, concatenate types of joins we can create on the data. Concatenate and merge. Okay. Then, what else was there? Let me again check. This was the concatenate merge. And before that, describe. These are the statistical functions, concatenate and merge. Then missing values, outliers, and duplicates. Awesome. Third will be missing values, outliers, and duplicates. Outliers and duplicates. Okay. Then fourth, what we will discuss after this is scaling methods. And even in scaling, we have three things. That is the standard scale, right? We have min-max scaling, and then we have robust scaling. Okay. Perfect. So that's what we will discuss today. And after this, at the end of the session, most probably in the second half, we'll see the steps involved to solve a machine learning problem. Steps to solve any ML problem. Now, there is certain sequence that we need to follow. What needs to be done first, what needs to be done after that, and everything. So that's something we will observe today itself, right? So that's going to be the agenda for today. Now we'll be discussing what we are going to discuss first, and then we will start doing the code and the concept, right? Perfect. So first of all, what we will be doing right now is the statistical functions. What are exactly the statistical functions? Basically, few functions are available in the pandas library through which we can calculate the mean, standard deviation, variance, and these kind of mathematical values on the data by just utilization of few functions, right? minimum value, maximum value, percentile values, and all those things we can calculate using these available functions in pandas. Now let's see what are these functions and what kind of results we can get. There is some access attribute as well, so we can also apply the access attribute and see the results. Okay, so we were working with this data frame QUANT quantdf. We created this data frame yesterday, if remember. If we remember, we have created this data set yesterday from the data object in which we only included the numerical columns. We excluded everything that is not numerical. And wait, quantdf, let me show the info. Yes, so if we check the info of this data, all the columns what we have right here, they are numerical, means the data type is float 64, right? Now the statistical functions what we are talking about here, they can be applied on the numbers only, right? These statistical functions like sum of something, average, mean of something, variance of something, standard deviation, minimum value, maximum value, and all those things, that can be only applied to the numbers, right? So that's why these functions does make sense. Like we can also give describe function to the textual data as well. That will give some other statistics, some other information. But most of the time it will give some insightful information on the numerical data only. So quantdf is a data frame that has numbers only. All the columns in the quantdf are having only numbers. Now, when we invoke this describe function, specific describe function, it will return count, mean, standard deviation. See, these are the standard statistical values what it will return for all the columns, all the numerical columns. So count of school rating, so count is going to be exactly same for all the columns, because that's the number of values we have, and every column is going to have the same values until and unless there are some missing values, like here we have, right? Otherwise everyone have the same count value. Now the average values, the standard deviation, the minimum values, the quartiles, and the maximum values. So these are some statistics that we can extract about our data set. Easy? Awesome. So that was about the describe function. Now the next, what if we apply this describe function on the data that has only text? So first of all, we need to have the data that only has the text. For that, we are using select d types. O stands for the object. So it will only select the data that, okay, let me show you the data first. Okay, so if we do df.select d types O, it will only select the object type of data, means the columns that have data type string, right? Yes, guys, make sense? Select d types O only returns the columns with the data type object. Then we'll be doing dot describe function that will give the descriptive statistics. And what are descriptive statistics? These are some values that return on a non-numeric data, that is the text data. Count, that is again same as the numeric data itself. Unique values means how many out of the text columns, like out of the text data, how many of them are unique. So if we check the name, out of 347, 341 are unique, and we have 6 duplicates, and that is pretty fine. School type, in school type column we only have 4 unique values, so these 4 unique values are getting repeated 347 times. Top means the value in name that is occurring maximum, means most frequent, we can say mode, right? So this is the mode of name, and this is the mode of school type. Frequency, what is the mode of frequency? Sorry, what is the frequency of mode? So this Liberty Elementary is repeating 3 times, and public is repeating 292 times. So in this is what we get in the text data: count, unique, top, and frequency. And this is what we get in numeric data, that is count, mean, standard deviation, minimum, quantiles, and the maximum value. That's about the descriptive statistics. Easy, everyone? Yes, awesome. Now, okay. So right now, see, it is creating a data frame, right? This is creating a data frame. This is creating a data frame. The describe function on any data set is actually giving a data frame where one axis is the statistical functions and other axis is the columns, right? But if I need mean, median, and object type, okay, that we'll see. There is an aggregate function. Okay, object type. Then how to get? We cannot calculate mean for the object type. Median also we cannot calculate because object type of data cannot be arranged. Mod is something we can definitely calculate. We have mod function, but we cannot calculate mean and median for the object type. In case we have numerical data in object type, then in that case we need to convert the numerical. We need to convert the data type of that column. That could be a human error or any possible way that we have something numerical, but the data type of that column is not numeric. It is an object. So in that case, we need to convert the data type. Then we can calculate the mean and median. Because if we see the formula, mean is sum of the values divided by the total number of values. That is something we cannot calculate in strings. Make sense? Perfect. So now, okay, the unstack. Again, let me explain what we are going to discuss here. The describe function is actually returning the result in a two-dimensional data. That is a data frame where we have two axes. One axis is about the statistical values, what statistical values it is explaining, and the another axis, that is the column, is all about the columns, what columns we are having in the data. So it's having actually two-dimensional data. Now, suppose quantile, sure. Quantile is basically percentile values. We know what is percentile. We know what is percentile. Right? You know what is percentile? So quantile is 25 percentile, 50 percentile, and 75 percentile. Quantile is 50 if you know percentile, so quantile is 25 percentile, 50 percentile, and 75 percentile. Okay. If you know the percentile, so 25 percentile, 50 percentile, and 75 percentile are basically the quartiles. Correct? That's it. Yeah, exactly. Q1, Q2, Q3. We are getting it right here. Okay, perfect. Now we were discussing about this value, what this describe function returns. It is returning a two-dimensional array, but suppose we want to make a bar plot of it, right? We want to create a bar chart of it. So we actually need, in case of bar chart, we need it in a one-dimensional only, the index and the values. How we can achieve that is simply using by the unstack function. So see, df.describe returns two-dimensional array, but if we do df.describe.unstack, it will simply unstack this two-dimensional array into one-dimensional array with multi-index, right? School rating, we have multiple values, multiple index again for the school rating and their values. Similarly, there will be another column, all the possible, statistical functions for that column and their values. Yes, that's what unstack is doing. Unstack is basically unstacking the two-dimensional array into a single series with multi-index. Easy? Unstack? Now, what exactly is the practical use of unstack? Nothing, just the visualization. When it comes to creating a plots and figures, this kind of data is more helpful than a two-dimensional data. Yes, yes. Awesome. Now, after the unstack, okay, we can calculate the mean by just going with the mean function. So by default, dot mean function will give the mean of every column. But if we give dot mean axis equals to 1, it will give the mean of every row. For example, this is the data. This is the data. Okay. We have the columns like this, and similarly we have the rows. We also have the rows. So when we simply do dot mean, it will give mean of this column, mean of this column, mean of this column, and mean of this column. Easy. If we simply calculate mean, it will give the mean of this column, this column, this column, means it will return 4 values. 4 values, right? It will return 4 values, 4 means. But when we do dot mean, axis equals to 1, then it will give the mean of this row, then this row, then this row, and likewise for all the rows. And that's what we are getting here. So our data has 347 rows. It is giving 347 mean. Correct? Yes? Unstack will try to unstack the data, means if the data is 2-dimensional, it will make the data into 1-dimensional with multi-index. Okay. Unstack will simply unstack the data. If the data frame is in 2-dimensional, it will make it in 1 dimension with multi-index. Axis equals to 1 means column. Actually, axis equals to 1 means column in case of the concatenation and the shape, other things. But right here, axis 1 will give row-wise, row-wise mean, and axis 0 will give column-wise mean. Actually, it is column only. When we give axis equals to 1, see, it will pick the values from the column and calculate the mean of these values, right? It's not reverse. See, it's just a way of understanding the thing. If we see in axis equals to 1, it is picking these values, right? And it is calculating the mean of these values, right? And it will pick these values and it will calculate the mean of these values. Now, it's not like it should or what it should do. What it is doing, observe what it is doing. Axis equals to 1 is returning the row-wise mean, right? So if, what is this 107? This 107 is mean of this value, this value, this value, and this value, right? Yes. And it is actually picking the values from different columns. It is actually picking the values from different columns and iterating the rows. But like if we say 1 means column, it is actually picking the values from columns itself. Guys, this is just the way we understand how what is axis 0 and what is axis 1. If we don't give anything, it's axis 0, and in case of that, it is giving the result like that. Again, I'll repeat this entire thing, guys. Wait, the confusion again arises, so let me repeat this entire thing. Everyone, please take care. This is the data. This is the data. Okay, we have different columns. Column 1, column 2, and 3 and 4, right? And we also have different rows. Yes, when we do dot mean, axis 0, axis equals to 0, or we simply do dot mean because that's the default also. Simply we give the mean. It will give us the axis 0 or only dot mean will give us the average of this column, this column, this column, and this column. So it will give 4 values, right? Clear access 0? Yes. Clear access 0? Now, the way we understand 0 means row or column, it's completely different. I could say 0 means rows. See, I could say access 0 means rows because it is calculating the value, it is calculating the mean of the values in a row, right? Across the rows. And someone can also understand it by the way like it is actually giving the mean of the column. So it is completely up to you guys how we want to save it, right? So access 0 will give us the mean this way. Access equals to 0 will give the mean this way, right? And if we do access equals to 1, similarly, if we do access equals to 1 dot mean access equals to 1, if we do it like this, it will give us the mean of all the rows like this. So it will get the values across the columns and it will give the mean. Then again it will get the values across the columns, it will give the mean. That's what we are getting here. Clear everyone? Easy? Awesome. Perfect. Now let's proceed. Let's proceed. What's next? Okay, like we have mean and sum, we can calculate the variance, standard deviation, count, and other things, right? We want some specific statistics to get, we can simply use aggregate and specify what all we want. Okay, easy. We only want sum and mean, we can use aggregate. We only want minimum, maximum, and the variance, we can use aggregate. So basically aggregate, we can give what specific things, what specific calculations we are expecting from the data. Okay, open this file in practical lab just to show. You just need to upload the file in practical lab here. It will take some time to launch my practical live, guys. And you also need to upload the data set. Okay, let this, your work area is getting restored. Okay, let this open. Meanwhile, we can discuss. Once this is launched, I'll show you how to open it. Yes, guys, this aggregate is clear. Easy. Awesome. Now the next concept is the group by function. Next concept is the group by function. Basically, what is a group by function? When we try to group the data with some category and try to extract some some aggregate function over some continuous variable. So for example, right now we are trying to create some random data set here. Okay, some dummy data set. So the data set looks like this. We have 3 columns: team, rank, and year, team, rank, and year, and we have some information in it. Okay. Now, what are the possible categories in which we can actually group the data? Anyone? Nested list? This is not a nested list. This is a dictionary, guys. Country and rank. Basically, country and rank, both country and team and rank, both can be utilized as a category, right? Team and rank can be utilized as a category. Okay, so we can simply use df.group by, specify which column needs to be utilized to create the groups, and then if I'm using count, it will simply give how many times that group is getting repeated. So df dot group by team and rank. So these are the groups, team, rank. Australia 1 is a group, England 3 is a group, India 2 is a group. So these are basically the groups. And the count means we are calculating the count aggregation, means it will give the count of every group, how many times the group is getting repeated. For the better understanding, let's observe another example for the same, this df data. Okay, the same data, middle TN school, what we have been referring so far, the same data. So see, right now we are doing group by over school type, and we are calculating the mean, right? So if I remove the last entity, group by school type and calculate the mean, so it will give the average for every school type, right? The average, the mean of all the columns for every category that is there in the school type column. Make sense? Easy? Perfect. Okay. Feel free, guys, if there are any questions, you can just put your questions at any, like, if while we discuss something, you can put your questions. Awesome. So clear the group by function as well. Group by and pivot is not actually same. Group by is specific for one, continuous variable only. But in pivot, we have a lot more flexibility, and in which we can create multi reports on multiple columns as well, right? It is already available. This file is already available in Google Drive, day 2. The file is already there. File and dataset is already there in day 2. Sure. The group by function is trying to group the dataset with respect to some categorical variable. So this was our dataset we are already familiar of. Yes, guys, this data frame, this dataset is something we are already familiar of, right? So we can see this school type, where it is. Yeah, school type is a categorical variable. The school type is a categorical variable. So in this data set, we are trying to data with the school type. We are trying to group the data with respect to the school type. So it will create the categories of the school type. There are 4 categories, and it is giving the mean of every other numerical column. Okay. Asking about the result which we got. So that is the mean of school rating in public. This is 3.09 as the mean of school rating in public category, mean of school rating in public charter category, mean of public magnet, mean of school rating in public magnet category. So that's the mean of the values for that specific category. Perfect. Clear, guys? Group by is clear, everyone? Easy? Let me put on the charger. Yes, we will get all. If we want specific, we can simply slice a column like this. Perfect. Group by is clear, everyone? Okay, now tell me, what is the data type of this result, guys? What is the data type of this result? Series. That's the series. True. So if I save it and if I check the data type, it will return series. Awesome. All series, because this is a one-dimensional array. Yes. I'm so sorry. Not one-dimensional array. This is one-dimensional data, right? This is data frame, and this, what it is returning is only one-dimensional, means the values and their index. So that's how it's actually a series type of variable. Easy? Perfect. Now, okay. This is the group domain data in which we have this school type and the values. Now, if we execute the reset index function, what does this reset index will do? It will simply erase the previous index and create a new index from default, like 0, 1, 2, 3, and so on. Okay, see what it is doing. It is removing the default index, that is public charter magnet and whatever it is. It is just removing that index and creating a default index 0, 1, 2, 3. So it is actually saving it as a column. It is saving the existing index as a column and creating a new index by like exactly what is its job. Its job is to create a new index, a default index. So if we don't want to lose the existing index, it will preserve it in a column. If we want to lose it, we can simply give drop equals to true. It will not preserve the original index. Easy. Reset index function. Sure. So we have this data as a series, and when it comes to a series, what are the attributes of a series? This is the index and this is the value, right? This is the index and this is the value. Okay. Reset index function will reset this index, means it will create a new index 0, 1, 2, 3, and that's what it is doing. So what about the existing index? It places the existing index as a column and it creates a new index. But when we did drop equals to true, it will drop the existing index. It will simply create a new index and the value. Correct? School rating given to the result. You are talking about, okay, the grouped by. Yes, we have stored this group by result into grouped mean method. Sorry, grouped by methods result into this grouped mean variable. Okay, in the next line old index is coming, but it's not the index anymore, it's the column for a data frame. This is not the index anymore, this is the column of a data frame, but that is the index. You mean to say, okay, so it's not actually saving it in the original object. I got your point. This is not saving it in the original object. In order to make this change, in order to save the change, we need to do this or in place equals to true, anything. Either we assign like this or we do in place equals to, then only it will get stored. Correct? Perfect. Perfect. Easy guys. Reset index function. How can we give our own customized column as the index in reset index to a data frame? In reset index, it will simply reset the index. If we want to give our own customized column, we cannot do it with the reset index. We can do it with the way we discussed yesterday. df.index equals to assign whatever customized index we want to give. Yes, emp0, emp1, and that specific thing. What is dropped here? Reset index, school type. No, it will drop the index. Whatever is the index, it will simply drop it. So if we see the grouped mean, that was the index, it will drop the index, right? In the grouped mean, this public charter, this was the index. Now when we made drop equals to true, the index is dropped. It is only having a new index, right? Easy. Awesome guys. So that was about the statistical functions. That was about some statistical functions that we discussed. Yes, just to drop the existing index. If we don't need it, we can simply drop it. Okay, so that was about the statistical functions. All clear? Can we drop multiple index? Definitely. Like if there is multiple index, if there is multi-index, everything will be referred as a dot index. So when we try to drop index or when we try to create new index, it will impact the entire multi-index. Okay. Yes, guys. Statistical functions. Index equals to false is used in .2 CSV when we write some data into CSV file and we don't want to write the index column. Don't want to write the index into some column. Okay. Statistical functions clear, everyone? Okay. Now this way we are all good. Everyone. Now, anyone is facing any difficulty in understanding, or we are good by going this way? Yes, please. Help me with some feedback. Are we good with this approach or anyone else facing any challenges? Sure. Awesome. Awesome. Thanks, guys. Thanks for the quick feedback. I think we skipped short values. I'm so sorry if there is sort values. Where is sort values? Where is sort values? Possibly. I'm so sorry, I don't see short values here. Oh yeah, here it is. Sort values is basically to arrange the data with some specific column. Sort values is to arrange the data with some specific column. Suppose we have, okay, in that case, we need to remove one of them. Short values is simple to arrange the data with some specific column. Okay, so there is a school rating. I want the school rating to be in descending order. So now we can see the result as in descending order of the school rating, right? That's the sort values. Now in sort values, we can give any column. If it is an entire data frame, we can give any column to sort the values. Easy sort values function, guys. Awesome, awesome. Add showing error. Yeah, what error it is showing? Okay, make sure we are actually working on the same column. It might be showing key error or something. Key error must be because this pivot. How can we can give the list of two values? We can definitely give the list of two values. Let me. Okay, in that case, oh, there should be two columns or there should be two levels of sorting, right? Let's say, let me pick some example for two levels of sorting. Suppose we want to sort it with region first, and then after the region, like two categorical sorting. In that case, we can give two values. Let's use some data set to understand the two-way sorting. Okay, here is the sales data. Let's again get back to the sales data. Yes, this is the sales data. Okay. Now suppose we want to sort by customer and region. Okay. We want to sort by customer and region. So in that case, we just need to give sales. Let me make it sales dot sort values by equals to list of first customer, or let's first arrange it in region. It's I think already arranged in region, so let's arrange it in customer and then region. Customer, comma, region. Oops, my bad. It should be in quotation. Yes. So see, it is first grouping by, it's first sorting by the customers, right? Now inside the customer, if okay, let me just convert it to dot CSV and let's observe the result in Excel. Uh, Sorted data demo dot CSV. I don't want to do index, so I'll simply do index equals to false. Okay, so it must have stored the index. How the strings values are arranged? Strings values are arranged with alphabetical order. Yes, strings values can be arranged in an alphabetical order. Sorted data demo.csv. To CSV is basically to write some data frame in pandas to CSV file. Yes, to export data into the CSV. Okay, now if you see, we have a single customer, and for this Amazon we have all the regions: Midwest, then North, then Northeast, then Southeast, then again West, and then we have the second customer, and then we have all the regions for that second customer, and so on, right? So that's two way of sorting works. That's how two way of sorting works. We gave first customer and then region, so it will arrange the data with customer first. So first it has Amazon for all the reasons for Amazon, and if you see, the reasons are in alphabetical ascending order. M comes very first out of this all possible N, again Northeast, then what else is there? Southeast, West, and again Midwest is for another customer, right? Understood? Sorting, guys. Awesome. Yes, tell me which part. Yes, Praveen, please let me know where if you want to show up to two decimal place in the data frame, how is it possible? We have round functions, we can do it with those round functions and all. Round, we can definitely round off the values. Yes, someone asked for the explanation. It's sorting both columns correspondingly. Not correspondingly, one by one. It will sort customer first, right? So if you see the customer, we have Amazon. A comes first, then we have this one. C comes after A. Then we have Excel. Excel's very something is there. Yeah, Excel's very fun.com. E, right? So it will sort the customer first in ascending order from A to Z. Now for every specific customer inside Amazon, all the regions are sorted in ascending order. So alphabetically, M comes first, then N, then Northeast, then again West, then again. Okay, after West, Midwest comes for the new customer. Correct? Yes, guys, clear? Awesome. Awesome. So let's proceed. I should close this also. Perfect. Okay, and if I tell you this replace thing, why is it replace here? If you observe, the cost of goods sold and the sales variable are having some dollar and comma symbol, so they cannot be converted to numeric data type, right? If we see this data, if we see this data, the cost of goods sold and the sales column has some string characters so that it cannot be converted to the numerical data type, float or integer something. Yes? Okay, so how we can deal with this? How we can deal with this? We are using the replace method to replace the dollar and comma with nothing, and then we convert it to float type. Okay, so cox dot string dot replace the dollar and this comma will be replaced with nothing, means they will be removed, and then we are converting them to float. Why we put, sir? We haven't placed it there. This is how our data is. This is how what we have in a CSV file. Okay, but if we want to deal, if we want to treat them numerically, if we want to process them numerically, we need to remove these dollar and the comma symbols, and that's how we are actually removing the dollar and the comma symbol and then converting them to float type. Easy? I'm speaking about string dot replace. This is basically to access a string function. Replace is basically a string function. We want to access this replace function that belongs to a string type. It belongs to a string class over an entire series of a column, entire series of a data frame. So that's why we need to specify .str alias and then the function for the string function. Here we can use integer, but in that case the decimals will be lost. Okay, Praveen, what is the purpose of doing this? Anyone wants to answer, Praveen? What is the purpose of doing this, guys? Anyone wants to answer why? What is the purpose of doing this? Simply converting data to numeric. Simply converting the cost of goods sold and the sales to numeric, because they are the numeric column. They are not string type of data. They are not text. They are numbers. So we want to convert them to numbers. That's why we are doing it. Correct? Awesome. Yes, guys. Now I hope we are good with this first agenda, that is the statistical functions, and we can start with the concatenate and merge. So before we get into the code and other things, let me brief you what we are going to discuss in concatenate and merge. Before we proceed, I see the previous line quickly. Sure. You mean to say this one, or which line? Dot two CSV or this one? String dot replace? 133. Yeah, here it is. This is basically we have arranged the data and then we are exporting it to a CSV file. We just give the name of the file, index equals to false, because we don't want to store the index in CSV. Got it? Awesome. Okay. So this first agenda is clear, everyone? Yeah. Now please let me know if anyone have any question before we proceed to the next thing, or else we can proceed to the concatenate and merge. Result of cell number 88. It will not result, it will not return any result. It is making the change and saving it in the column. So after executing both the cells, you see the cogs and sales are not having any string characters anymore. Okay, Shruti, I'll show you it in during the break. Okay, I'll show you that in break. Okay, that will be okay. That will be fine, right? I'll show you in break. Where it comes, where when we discussed null hypothesis, Abhijit, are these codes available? Yes, yes, these are available. in the Google Drive. I have shared a Google Drive link yesterday. There is a day 2 folder, and there we have the code and the dataset, everyone. Okay. Yes, thanks, Adit. Thank you so much. Yes, that everything is there in the Google Drive, guys. Everything is available. Day 2, here it is, sales.csv. Here is the pandas basics file. Here is the demo dataset. Okay. Today is day 3, and I think there is nothing to upload in day 3, but let's see. Awesome. All good. All good. All good. All good. Yes, guys. Any questions about the statistical functions? Great. So before we discuss the concatenate and merge, let me give you a quick brief what exactly we are going to discuss in concatenate and merge. Concatenate and merge is all about combining two data frames, two tables with respect to rows or with respect to the columns, right? What all functions can be used with group by? All possible aggregate functions we can use with group by. Means mean, count, or what else was there? Standard deviation, variance, minimum, maximum. All possible aggregate function we can use with group by. Even describe we can use. So when we do dot group by, we can use all aggregation function. Okay. Perfect. So concatenate and merge. Concatenate and merge is basically all about combining the data frames. Okay, so let's say this is the data frame A, this is the data frame B. Okay. Either we need to combine them like this, or we need to combine them like this, right? This is called with respect to rows. This is with columns. Okay. So all these things we will be discussing in concatenate function. Now in merge and in join, basically we have the concept of joins. What are joins? Basically there are 4 types of joins. Yes, access will be involved here, exactly. So either we need to combine them with respect to rows, or we need to combine them with respect to the columns. Whatever it is, we need to specify using the access itself. So that we will see during the code. Okay, now in joins, we have first inner join. What happens in inner? If there are 2 data sets, it will only consider the common one, right? The observations or the values that is common between the two, and this is often called intersection. Second is the outer join. What happens in outer? It gives everything whatever we have, right? Then right, in which we will only get the data from the right data frame. Okay. And the fourth is left, where it will only give the data from the left data frame. So in inner join, if we have data frames A and B, okay, let me mention 2 data frames A and B. Okay. So if we have 2 data frames A and B and we do inner join, they will give the common data only. Anything that is common with respect to both the data frames. In case of outer join, it will give everything what's there in A and B both. In case of right, it will only give the values from B data frame. In case of left, it will only give the values from A data frame. So that's the join concept. Except the left and right, outer join gives whichever not matched in both tables. No, full outer join will give everything that is there in both the data frames, even if it is common or if it's not common. It will give everything. We'll see with the code itself what the outer join gives. We'll have to observe it. But right now, outer join will give everything in both the data frames. Okay. Outer join skills, whichever. Perfect. Any questions? Is there any use of self join? No. Right now we will be discussing these four major joins only, and they are more than enough. Now we have two different functions, concatenate and merge. Every function have its own limitations and own benefits. That is something we will discuss while we implement the functions. Okay. Now, if we talk about the joins, guys, we need to have some key, right? The concept of key is here. Key means what column we should refer to create a join. Whenever we talk about a join, the key should be there, right? For example, there is the table for the products and there is a table for the brands. Or let's say there are two shops, okay? The products from shop 1, products from shop 2 needs to be combined. So while creating the join, we need a key. Let's say a product ID. Product ID is going to behave as a key and we will observe the product ID to consider which data should be used, right? So we need to have the key while we create a join. Make sense? Or if we won't use the product example, let's take an example of the students. We have two sections, section A and section B. Okay, we want to see the students from both the sections. They like the students that are studying the common subjects in both the sections, section A and section B. How many students are studying the same subjects? So that is some sort of inner join, and the key should be the subject ID. We should pick the data where subject ID is available in both A and B. Yes, make sense? For example, if we want to extract the students that are studying the same subject in both the sections, so we need to use the subject ID as a key and we need to extract the data where subject ID is available in both the data frames. Right? So understood what is exactly key here? Awesome. Key is clear, everyone? The joint and the key. Yes, the common column that is available in both the tables. Correct. Clear, everyone? Perfect. Now let's jump to the code and let's see how exactly these functions work. So first of all, when we what is this? Oh, debugging v6. Yes, this is what we are doing. Yeah, we need to start it from here. Okay. Now, first we will be discussing the concat function, and let me give you the limitations of concat function. Concat function. Now the benefit of using concat function is it can work on both axes. Axis equals to 0 and 1. It will work on both. Ideally, if we talk about these concepts, they are only work on axis 1, right? The joins are, joins are basically the concept when we are trying to combine the data frame like this. Then only the key and the type of join is something we need to take care of. Yes? The joins are only when we combine the data with axis 1, that is this. If we have the data frame like this and like this, there are columns and we need to combine them using some key this way with axis 1, then only we take care of the joins, right? Yes? It is clear, everyone, that the joins concept, inner, outer, right, left, whatever it is, that is something we apply when we combine the columns with respect to, sorry, we combine the data with respect to columns, with respect to axis 1, like this way, this specific way, right? Then only the joins concept comes into the picture. Okay, so this joins are something we do when the access is equals to 1. Here, when we implement the concatenate function, we can use access 0 and 1 both. Means the concatenate function, the concat function is capable of making this type of combination and this type of combination both. But when it comes to the merge function, it is only for access 1. It is only for access 1. Right? One difference about merge and concatenate. The concat function can do both access 0 and 1, and merge can do access 1 only. Difference between group by and concat. Concat is basically it's basically combining two columns. Concat is basically combining two data sets, data frames, and group by is something we apply on a single data frame, right? To group a given categorical column. That's what group by is. In group by, we only have a single data set and we try to group that data in that specific data set with respect to some categorical column. That's the group by. But this concat function, it is completely different than group by. Concat is something when we try to combine two data sets with respect to some access, 0 or 1. Okay? Is merge and join are same? Actually, merge and join, yes, merge and join. If you are asking about the join, they are similar functions. Just the way their parameters are little different, but they yield same results. Okay, now let's come back to the concatenate and merge function, guys. So first of all, in concatenate, we can create the joins with access 0 and 1 both, but in merge, we can only do it with access 1. That's the first thing between merge and concatenate. Clear? In concatenate function, in concat function, we can combine the dataset with access 0 and 1 both. In merge, we can only do it with access 1. That's the one difference. Second difference, in concat, index is always the key. Index is key. Always. The index will always be the key in case of concat function. We cannot give any customized key. But in merge, we can specify custom keys. Means any column. Right? We can give column as a key in merge, but we cannot give column as a key in concat. Okay? We can use some specific column as a key while creating a join in merge function, but that is something we cannot do in concat. That's the second difference. Key, basically, we are referring to the key what we discussed here, right? The common column in both the data frames. The common column in both the data frames. So we are actually talking about this key. Here, in case of merge function, we can give custom key, means any column we can tell merge function that refer to this column as a key. That is something we can give in merge. But in concat, we cannot do that. Index will always be the key. Correct? Index will always be the key in case of concat, but in case of merge, we can specify some custom column to be utilized as a key. That's the second difference. And I think that's it. There is nothing else between concat and merge. Yes. Yes, guys, got the idea about what exactly is limitations of concat, what are benefits of concat, and again for the merge as well. Yes, guys. Now we will see the code. Sure, in concat function, we can combine the data frames in both the axes, 0 and 1 means we can combine them vertically, horizontally, both way. And the index is only going to be utilized as a key when it comes to the concat function. But when it comes to the merge function, we can specify any column as a key as well. Okay, access means in concat function, we can combine the two data frames horizontally and vertically both. If we see this is what access means. In concat, we can combine the data frame like this also and like this also. But in merge, we can only do this. That's the difference about the access. Clear? Yes, guys. About the access in concat, we can do the combination both ways. Like we can combine them with rows as well and columns as well. But when it comes to the merge, we can only do this way. That's about the access. And about the key, only the index will be the key for concat function. But in merge, the column can also be utilized as a key. Clear? Now let's see the code. After the code, it will be more better. It will be more clear about the merge and the concat. Let's see the code then. I'll keep these annotations right here. I won't erase them. We are simply creating two demo data sets, 1 and 2. Okay. So this is how data frame 1 and data frame 2 looks like. What we have: name, subject ID, marks code, name, subject ID, marks code. Consider it the students of two different classes. Okay. Let's consider these are the students of two different classes. Okay. Now, see, we are trying to concat 1 and 2 with access 0, means it will combine the rows. And that's how the data looks like. Easy? This was the data, two students from two classes, and we combined with access 0, that is actually the rows, and both the rows are combined. Sure. This is data frame 1, this is data frame 2, and when we did concat 1 and 2 with access 0, that's what the result is. It will simply use the same index what the original data frame had. It is using the index what the original data frame had. We can do the reset index. We can do the reset index for that. Okay, if it has different columns, good catch. We'll see what will happen in case it has different columns. I'll just show you what will happen in case it has different columns. Perfect. This is clear, everyone. Access equals to 0. Append and concat. Append will simply append the rows, but concat is actually it can concat the two data frames with access 0 and 1 both. Right now it's like an outer join. Right now what we are getting, it's basically an outer join. Okay, so this concat on access 0 is trying to combine the two data frames with respect to the rows. Is it clear, everyone? Concat on access 0 is trying to combine the two data set with respect to rows. It is clear, everyone? And right now, if you observe, both the data frames were having the same column, so the resulting data frame is also having the same column. Okay, now here my question is, if we see the index are getting repeated. And what will happen if you try to access the data with the index label 1? Yes, if we see the index are getting repeated. And what will happen if you try to access the data with the label index 1? Will it give both? It will give 1, it will give error. What will happen? It will show first one, second. Okay, let me try to do it. And here we go. It will actually give the both. It will give the both. Okay, it will give the both. That's why we have user defined labels. If we only want to access one, we can use system defined index using iloc. System index will not mutable. Yeah, if we do iloc, we cannot update the system index at all. We need to use the same as what is the position as per the index order, right? It will give both. Or yeah, as per the index order. Yes, correct. As per the order, it will give both. True. Okay, is it clear, everyone? The concatenation with access 0 will combine the two data frames with respect to the rows, and the index labels are getting repeated. If we try to access a certain index label, it will give all the possible values. Clear? Now let's proceed. Okay, now see, this is access equals to 1. So in that case, we need to use iloc. If you want to access it with the system index, we need to use iloc. Okay. I did iloc and it is only giving 1. Can we can update index using sequence? So sorry, I didn't get it. Means you mean to say this index, we want to update this index the same way what we discussed in EMP part. The same thing what we saw in EMP thing. Remember, we updated the index of a series utilizing a list comprehension EMP1, EMP2, EMP3. That is what we can do. Okay. Set index is also there, like we can give some column in set index and we can give the list comprehension. Okay. So these are the possible ways to update the index in the data frame. See, the result is the data frame. So what all we can do with the data frame, that's what we can do to this result also. Okay. What it is returning is a data frame. So what all possible things we can apply on the data frame, we can apply on this as well. Easy? Then, okay, now see the concat on axis 1. This is what it gives on axis 1. Okay, now here is a small catch, guys. Here is a small catch, and what is exactly that? See, in our data 1 and 2, observe the index. Observe the index. 5 is not available here, 6 is not available here, right? Yes, and we saw that index is always the key in case of concat. Index is always key in case of concat. Remember? Now let's observe its result. Let's observe its result. Okay. See, 5 was not available in data frame 1, so the columns of data frame 1 is having nan, and the 6 was not present in data frame 2, so the columns of data frame 2 are having nan. Right? The 5 was not present in data frame 1, so the columns for the data frame 1 at index 5 are having nan, and the index 6 was not present in data frame 2, so the columns for the data frame 2 at index 6 are having nan. Easy? Now this is something we can simply remove by doing the inner join in concat. Why index was considered as a key in axis 0? Because that's how concat function works. In case of, okay, we'll come to that part in axis 0, index will not be the key, the columns will be the key. We will see when the columns will be different. Just allow me some time. We'll reach to that part and we'll observe what will be the key in case of axis equals to 0. Okay. Okay, sir, why index is not starting from 0? Because it completely depends upon the index what is there in the original data frame. And these are the user defined index, not the system index. So this is what we have created. That's why it's starting from 1. Okay. These are user defined index, not system index. And we have created them 1, 2, 3, whatever it is. We have created them. That's why they are starting from 1. Perfect. Now this is clear, guys. This is clear, everyone. 5, 6. Awesome. If nan is a null value, exactly. Nan is basically the null, not a number. Nan stands for not a number, and that's the missing only. Null, none, anything we can say. Okay. Now, after this, if we do specify join in case of concat, it will not give 5th and 6th because the index is not common in both the data frame. Okay, sure. Let me increase the size. Better now? Okay, now we gave the inner. Now we are not getting 5 and 6 because we saw in case of inner join where it was. Yeah, in case of inner join, it will only give the common keys. And the index is being treated as a key here. So it will only give the common index. It will only give the common index, that is 1, 2, 4. Easy. Now, in case of concat, we cannot use any other join also. In case of concat, we can only use inner and outer. By default, it gives outer, what we saw here, and possibly maximum we can give the inner itself. Again, let me sum up. Let me brief out what is the concat function. Concat function can be utilized to combine the two data frames with respect to the rows and the columns both, right? Index is always the key. Index will always be the key, like we saw here in concatenation with respect to the axis 1. Index will be utilized as a key. By default, it gave the outer join where it gave all the possible index, but we can possibly give it inner join in which it will only give the common index, that is the common keys. Correct. That is all about the concat function. We are yet to discuss one thing in concat, that is in axis 0 what will happen in case of different column names. So apart from that, are we good till here? Awesome. Awesome. Now let me show you what will happen in case if the column names are different in concat. So now we are creating with two column names, name and name2. Name and name2, right? So this is 1 and 2. Now if you see the data frames, the column names are different. This is name and this is name2, right? Yes? Okay, now let's see what will happen in case of axis 0. The same what happened in case of axis 1 with the index, right? So for name, these are nuns. For name 2, these are nuns. Exactly same what happened in case of 5 and 6. Remember? Just the axis got changed. That time it was axis 0. So the index were used as the key. Right now, that time it was axis 1. So the index were the keys. Right now it's axis 0. So the columns are the keys. And if we make inner join, it will only give the common columns, that is subject ID and marks, because name and name2 are not available. It will not give the name and name2. So what's happening in this case? Exactly same concept, only the keys are used, the column names are being treated as a key here, right? Yes. Okay, understood guys. Concat function, easy. Awesome. Awesome. Okay, now we can quickly finish the merge function, and then we can, what about left and right? That is something we cannot do with the concat. That is something we need to use merge in that case, right? In concat, we can only do inner and outer. Outer by default, inner we can give. Perfect. So let's understand the merge function now. This is, yeah, this is the data frame 1 and 2. Same columns, index again. Okay, now in this case, merge function, index have no significance, to be honest. We need to specify the specific column to be used as a key, right? Index were having the significance in case of concat function because index or the column names will be utilized as a key, but in case of merge, we need to tell which column should be treated as a key. So it will create a new index. Okay. In case of merge, the result will be having a completely fresh index. Okay. Perfect. So first of all, let's see how equals to outer. Okay. I'm trying to merge 1 and 2 with outer type of join, and this is what we specify as a key. Subject ID should be utilized as a key here. Okay. Now suffixes, the data frame 1 columns will be having the suffix section A, and the data frame 2 column will have the suffix section B. Let's see the result. Okay, see, this is the same data frame what we observed. Yes. Now if you see here in the data frame 1, section subject 3 is not there, right? Subject 3 is not there, and here subject 1 is not there, right? Subject 3 is not available in 1 and subject 1 is not available in 2, right? Yes, guys? Okay, now if you see the result, subject 1 is having nan because it was not present in second class, that is section B, name section B, marks code section B, nan because subject 1 is not there, and similarly for subject 3 it's nan in class A, section A, and section A is nan in class A. Correct? Easy? On is the key. Through on we specify the key. What should be the key in order to create a data, in order to create a join? Perfect. Understood everyone? Easy? Now let's do some experiment. What will happen in case of inner? The column names are changed because we have specified the suffixes here. If we see the function, there are suffixes what we are giving, right? Section A and section B. So all the columns of 1 are having the suffix section A, and the columns of 2 are having the suffix section B and section B. Easy? Okay, now what will happen if we make it inner? It will by default add underscore x and underscore y. If I remove the suffixes, it will by default give underscore x and underscore y. Okay? Yes, now see, we did inner join, so we are only getting the common subject IDs. We gave inner join, so we are only getting the common subject IDs that are available in both the data frames. Correct? Yes, not giving subject 1 and subject 3. Yes, easy. Now similarly we can give left and right. So what will happen in case of left, guys? In case of left, it will give all the subject IDs from data frame 1. All subject IDs from data frame 1. So 1 has subject 1, we are getting subject 1. Right? What is the difference in concat with access 1 and merge? Yes, guys, anyone? What is the difference in concat with access 1 and merge? Anyone wants to answer? What is the difference? Left and right will not work. Yes. Index will always be the keys. We can have different keys with merge, but in concat, merge can do left and right. And what about the key thing? What's the difference with respect to the key in merge and concat? Yes, guys, what's the difference with respect to the key in merge and concat? Key index is the only key. Index and concat, any key in merge. Yes. Awesome, guys. Awesome. Perfect. No, in concat, the index is only the key. In concat, index was only the key. We have not given any custom index. Okay, we have not given any custom key in concat function. The index was only the key. Please show the data on how equals to outer. We never specified any key in concat. By default, it will consider either the index or the column names. By default, if it is access 1, index will be the key. If it is access 0, column names will be the key. Okay? There's no use of left. You can just use the original data frame. No, it is giving the combination of both the data frames, right? The columns of both the data frames are available. If I give you the practical use, let's say there are two shops, shop A and shop B. We want to compare the prices of the products with respect to the shop A. We can use right join, right? If that product is not available in B, it won't show it. Yes, guys, clear? Let's quickly finish this and we can go on a break. The merge is clear. Now, the question will return the first data frame. The left will return the first data frame. The left will return the first one, right? True. And similarly, the right will take care for the second one. Okay. Now there is a small, trade-off. What if the key that is subject ID, they have different column names in both the data frames? For example, this is the case. We have subject ID 1 and we have subject ID 2. In that case, how will we specify the key? Yes. So in order to tackle this, we have instead of on, we need to give left on and right on values. Okay. We need to use left on and right on values. Okay. Perfect. All good, everyone? Why left on and right on? Anyone wants to answer, guys? Why left on and right on? Yes. Because the keys are actually having different column names in both the data frame. The data frame 1 and the data frame 2 are having the different column names. So that's why we need to give the key ID, the key column for data frame at left and the key column for the data frame at right. That's why we have left on and right on. Awesome. Yes, guys. Understood where the concat and merge join what all we discussed in the second agenda. Easy? Clear, everyone? Perfect. Now we can take a break, guys. Polling. Okay, I am going to my MacBook then. Okay, that's machine learning. And how are we doing? Yes, the polls are open, guys. Can we? But I have a cool question. Yes, yes, please go ahead. Let me know the questions, and meanwhile, I can start the timer. 17 minutes. Let's keep it in between 15 and 20. Okay, guys, if the question is related to exactly the same topic, we can discuss it after the break so that everyone will be there. If there's something else like about the lab or something, Shruti, I think was having the lab. Yes, let me show you the lab thing. Keep waiting. Okay, it's launched. Okay, this is the lab. This is the lab. You just need to upload the notebook. For example, I have this pandas basics file here. I'll simply drag it in the lab. Okay, this will get uploaded here. I'll simply drag that notebook file over here. This will get uploaded. Yes, time has already started, guys. It's going on here. Yes, Shruti, can you see? I can simply drag this pandas basics to this part and it will get uploaded, or else we can just go to this upload icon where we can select which file needs to be uploaded. Here it is, the list of topics. Dataset, we need to upload the datasets one by one. We cannot actually upload the entire dataset in a single go. So in that case, we need to upload one by one. I want to purchase a system PC. Please recommend for hardcore AI, ML, and DS. Just go with some graphic card. Any PC with good configuration of a graphic card would work. Let me tell you, the minimum maximum has no limit. You can go to anything. Minimum i5 8th or 9th gen is must, and 8 GB of RAM is at least something we require. M1 chip is brilliant. You can go with the M1. Go with the Pro M1 that has 8 GB graphic as well. So go with the Pro M1. SSD as per your requirement. Yes, even I'm also planning to upgrade. I would suggest if you are if you want to go hardcore DL and deep learning and AI, go with something with graphics card. No, in that case, prefer some, because graphic if you actually want to implement the deep neural networks and AI codes, you need graphic cards. You need graphic cards. So if you are actually trying to go with Mac, go with the Pro one that has 8 GB of graphic as well. It will cost you around 130K approximately. 256 GB one. 256 is 130, and no. 500 and yes. 512, I think. 512 GB is 130K. Yes, Mini will work for the small tasks. Mini will work for the small tasks, definitely. Perfect. Let's get back after the break, guys. Let's get back after the break. Hey everyone, everyone is back now. We are all back. Awesome. So, what's next? We did merge and everything. Next is something interesting that is we are going to discuss about the missing values, outliers, and other things, right? So we talked about the concatenate merge, and we will be talking about the missing values, outliers, and duplicates. That's what we will be discussing today. Okay. Perfect. So first of all, let's see the missing values. Now these are some conceptual things, so we need to understand the concepts and then we will do the code and other things. So first of all, missing values. Missing values. Okay. Now do we know what are missing values, guys? We know what are missing values. The data that is not available, the nans or the nulls are the missing, right? Nans or the nulls. These are called missing values. Okay. So we actually need some strategic approach to deal with these missing values. Yes. We actually need some strategic approach to deal with these missing values. Okay. Now, before we talk about any possible methods to treat them, why do we need to treat them? What's wrong with having missing values, guys? Yes, before we discuss about dealing with the data that's missing, what's wrong with them? Why we can't have them in the data? Not accurate data, misinterpretations, right? And also some mathematical equations cannot be implemented on null, right? Yes, filter issues, and there are lots of such concerns in which, because of which we need to take care of for the missing values. Right? Okay, now let's talk about the possible solutions for the missing values. So the one possible solution is central tendency imputation, right? Central tendency imputation, right? Now in this central tendency imputation, we can either use mean, median, or mod to replace with the missing values, right? Mean, median, or mod. We can either use mean, median, or mod in order to replace the missing values. But again, when we should use mean, when we should use median, when we should use mod, that is something to discuss. So in short, if we try to understand what exactly is this, wheresoever we got a value missing, we can replace that value with the mean, median, mod of that entire column. That's a possible way to deal with the missing values, right? Make sense? Yes? Perfect. Now, when we should use mean? So, mean when the data is normally distributed, right? Mean when the data is normally distributed. Median when we should use median? In case of skewness in the data, right? And when we should use mod? That is in case of categorical column, right? Categorical column. Okay. So ideally, we can use this three statistical values, mean, median, mod, to fill the missing values. When we should use mean, when we should use median, when we should use mod depends on the column, right? We fill the missing values with respect to the every column, and we need to check the data distribution. We need to check the data distribution before we decide whether we need to use mean and median. So we'll talk about the distribution. Mod, in case of having a categorical variable, we will be using mod. In case of continuous, this will be there when we will be using continuous, right? When the missing values are there in some continuous column, right? Some continuous variable, then we use mean or median. If it's a categorical, we can use mod, right? If it is categorical, we can use mod. If it is continuous, we can either use mean or median with respect to the data distribution. Now let me tell you what exactly is the data distribution. For that, let me erase all these things. Okay, if our data distribution or the frequency distribution plot looks like this, a bell curve shape, this is called normal distributed data. And if our density plot looks somewhat like this is skewed data. This is also skewed. And also if the data looks like this, that's also skewed, right? So this is called skewed, this is skewed, and this is normal distribution. So in this case we will be using mean, and in this case we will be using median, right? Easy? Easy? Perfect. Perfect. Then but how do you get to know if it is skewed or not? We have different visualization techniques. We will see while we implement the coding. We will see how we can check whether the data is distributed or not. Okay. Yes, also that's also the possible way. Mean is greater than median, or mean and median are quite close, then that's the normally distributed. But we'll see how we can make the plots and how we can see whether it's skewed or whether it's normally distributed. Okay, understood. If the data is skewed, we will be using median. If the data is normally distributed, we will be using mean. If the data is categorical in nature, we will be using mod. That covers the central tendency imputation of missing values. Clear? Okay. Second method, grouped mean. Okay, anyone have any idea about this grouped mean method of dealing missing values? Yes, please. Anyone have any idea about grouped mean? Okay, no problem. Let me pick an example. Let me take an example. Suppose we are working with grocery store data set, and we have two columns, item type, right? Sorry, we have item type and we have item MRP. Intem, what's intem? I'm writing item MRP. Okay, let's say we have two columns. Suppose we have a lot of columns, but now let's consider we are taking care of these two columns. Now there are some missing values in MRP. Suppose this is missing. Few entities are missing in MRP, right? There are some products for which MRP is missing. Okay. Now, one possible method to fill the missing values is to observe the distribution of MRP and decide whether mean or median. That's the possible solution to fill the missing values in MRP. Yes. Observe the data distribution in MRP and replace the missing values with either mean or median. That's the possible way. The another way is only replace to a specific item type. Let's say this is missing and the item type of this product is dairy, right? Suppose that's a dairy product. Now, instead of replacing it with entire mean, we will replace it with the mean of dairy products only. Make sense? Make sense? Instead of replacing this missing values with the mean of all the data, we will replace it with the mean of dairy products only. Got it? Similarly, there will be some type, let's say there is type 2. Okay. So here we will replace the average MRP of all the type 2 products. That's called the grouped mean method of dealing with the missing values. Understood? Easy, and this is even more accurate. Okay, now when we should do this? When we have some column that gives a meaningful insight about the column in which missing values are there, right? We can only use this column when we have item type for a given item MRP, because the type and MRP are going to have a strong correlation. In terms of domain understanding, we can simply say the type and MRP are going to have a strong correlation, right? Yes. So we can only use this when we have something like some category that gives some sense to the column in which missing values are there. Understood? Understood, everyone? Yes, clear? If I have only one, okay, there is something. Let me scroll. If I only have for item time, we can omit it. Yes, we can do it. We can do it. Perfect. Now again, these let me actually let me tell you the exact foundation of doing all these things. There is also a one good to follow rules. If any column has more than 30% data missing, we drop that entire column, right? There is also a good to follow rule. If any column has more than 30% data missing, we drop that entire column. So we can also mark this down as a note that if any column has more than 30% data missing, we should drop that column. Now, what is the idea behind all these things? Missing values are basically the anomalies in the data. They are something not good for the data, right? If there is some observations are missing, they are not good for us. So what we try to do we try to make some assumptions in place of those missing values such that we should not impact the original statistics of the data. Replacing the missing values with mean, median, mode, or some central tendency is not going to affect the original central tendency or original statistics of the data. So the idea behind doing all these things is to preserve the originality in the data by removing the anomalies. Yes, the missing values are something not good for us. So we need to do something to them. We need to treat them somehow. And we try to use any possible approach such that we should not impact the originality in the data. The original statistics of the data should not be hampered much. A little bit deviation is something we can still afford, but it should not be too much. That's why this is also a good to follow rules to treat such kind of anomalies not more than 15%. Because see, if there is some column that has huge amount of missing data, let's say 60% data is missing and we treated it with some XYZ approach. So in that column, 60% data is assumed. That's not accurate, and that's again going to impact our overall result, right? So we try to make these assumptions, these imputations, these treatments as less as possible so that we don't hamper the original statistics of the data. Make sense? That's why we have these rules of mean, median, mods, grouped mean. Now again, why I explained this entire foundation? Because we have good to follow rules, but they are not hard and fast rules. Something can have a lot of exceptions. So while we make a decision, we should keep in mind while like if we are following this step, whether it's going to impact the data in a very huge intensity, or we are going to preserve the originality. That is the main criteria we should keep in mind while selecting what should be done on what kind of data. Make sense? Perfect. Perfect. Please repeat what you said. Just explain in brief. I just said that all these imputation methods are only to remove the anomalies by preserving the data originality. So we should not do too much so that we lost the original statistics of the data. We compromise the originality in the data. That is something we should keep in mind. We'll come to outliers one by one, guys. We'll come to outliers. Perfect. The two methods of dealing with the missing values, clear? Grouped mean and there's central tendency imputation. The third method, okay, now let me tell you a problem in case of these methods. Okay, any questions? Okay, we are all good with these two methods. So if the missing data is more, we should eliminate the column. We should eliminate the column in that case, because that's not going to help us in further insights, because the data itself is not complete, right? The column itself is not complete. So we cannot trust that column much. Yes, if it's less, we can do the good to follow benchmark is 15%. We should not exceed more than 50%, but extreme cases we can proceed definitely. In the extreme cases, in the worst scenarios, we can go till 30%, but more than that, we should drop the column. There are also the scenarios, there are also the use case where we have most important column with 30% data missing. So we cannot drop that column, right? So we need to just take the decision accordingly so that we don't lose the original information. The possible way, we can drop the rows, we can drop the entire rows instead of playing with the imputation. We can drop the entire row. That's again a good approach, right? If we have most important column and that has 30 to 40% data missing, so like only use the data that is available. Don't use the data in which one column is missing. Drop that entire data. That is again a good approach. Definitely, there is no thumb rule, there is no hard and fast rule. That's why we say data science is basically an art of modeling. What needs to be implemented on what kind of data, what kind of use case, that's the art. That's what we gain over experience. How to know the percentage of missing data? Anyone wants to answer how to know the percentage of missing data? Info can help, right? Or just count the missing values divided with total number of missing values. Count the missing values and divide it with total number of data available in total number of records, right? The coding part, the functions, we will see what functions, what methods we can use to get the percentage. Conceptually, we can simply count the number of values missing and we can divide it with the total number of values. Easy? Easy? Even if we don't talk about the functions and what's available in the data frame, what's available in the pandas, conceptually, we can simply count the number of values missing in a column and total number of values available in a column. We will get the percentage of data missing, right? Yes, we'll talk about the functions and other things when we'll do the coding part. As of now, we can simply calculate it by getting the number of missing values, dividing it by the total number of information, total number of values available. Okay, the grouped mean is also clear, everyone? Awesome. Now, next, let me tell you some problems what we need to tackle in case of these methods. Suppose we have a time series data. Okay, suppose we have a time series data. The data is having some trend like this. Okay, this is the trend of the data. Possible, anything is possible. So now let me pick some values where we have missing, some values where we have missing. Okay, so these are the timestamps where data is not there. Now in this case, if we use any central tendency imputation method, we are going to get false results. We are going to get some false trends in the data, right? If we use any of the central tendency method, we are going to get false results, false assumptions. Yes? Not a good idea to use any central tendency method in case of these kind of data. So what is the possible solution? We can actually use backward fill or a forward fill. We can actually use backward fill or a forward fill. Means just fill the next value or the previous value. In backward fill, the missing values will be filled with the previous value. In the forward fill, the missing values will be filled with the next value, right? Easy? Backward fill and the forward fill? Everyone? Easy? Sure. Sure. So in case of such time series data where the data is indexed with time and we have a specific trend where central tendency imputation will not going to give some good results, we can simply replace the missing values with the next value or the previous value. And when we replace the missing value with the next value, we call it as a forward fill. And when we replace the missing value with the previous value, we call it backward fill. Okay? We can take the average. Yeah, definitely. That's obviously a solution. We can take the average. Okay, there is one more statistical method. Upsampling, downsampling is something different. That is what we do in case of imbalanced classes, not in case of missing values. Forward fill will take the backward info to front. Let's keep it simple, guys. Forward fill will take the next value to place in the missing value, where the data is missing, and backward fill will simply pick the previous value to replace where the data is missing. Easy? Awesome. Awesome. Okay. So that's about the missing values, guys. All good? Everyone clear about the missing values? Okay. Perfect. Now let's come to the next thing. Group mean and backward and forward fill is also something we discussed. Backward and forward fill. That's completely subjective. We can use forward and backward anything that is not going to give a major difference in the results. We can use anything, backward or forward. Perfect. Now the next thing is next major concern about the this is called data pre-processing, guys, right? This is what we do with the data before we do anything. Now second thing is outliers. Okay, now what are outliers? Anyone? Do you know what exactly are the outliers? Extreme values out of the range data, out of the bound data. Okay, for example, let me take the example of an outlier. Suppose we have a class of 40 students, 37 students are scoring good marks, 80-90%, and 3 students got failed. So these 3 students are the outliers, right? Yes, guys, these 3 students are the outliers. Are also in the other case where these we have 40 students where 37 students are actually failing and 3 students are only scoring 90% marks. So these 3 students are the outlier in that case, right? Where just Bezos resides. True. How will we know it's an outlier? That's what we'll discuss. How to detect the outliers. Yes. Okay. So we got the idea what exactly is an outlier. If out of 40 students of 40 class, sorry, in out of a class of 40 students, if 37 are getting failed and 3 students are scoring 90%, so these 3 students are the outliers, right? And we need to remove them out of the class because they are impacting the overall performance. Yes, makes sense. These are the outliers. So either we need to remove these 3 students who are scoring 90%, or we need to fail them. Then only we will be having a good normal distributed data. Okay, now let's see how do we detect them. How do we detect them? Again, there is a very straight, very easy method to detect the outlier, that is IQR method. IQR, interquartile range. We calculate the IQR value as Q3 minus Q1. Yes, that is basically 75 percentile minus 25 percentile value. And then we keep the benchmark of Q1 minus 1.5 IQR. Anything lower than this should be treated as an outlier, and anything above than Q3 plus 1.5 IQR. Interquartile range. Okay, data should be greater than this and smaller than this. That's the good data for us. Anything beyond this range is the outlier. Anything beyond this range is the outlier. So that's simple. That's how simple it is to detect the outliers. Simply calculate quartile IQR and use this formula to have the lower and upper benchmark. Anything beyond this is an outlier. I'll upload these whiteboards, and if you can keep a pen and paper handy and write on the notes along with the session, that will be really great. Because let me give you the honest feedback, these whiteboards, while we discuss and type, while we annotate and discuss, makes much sense, but when you will look at them after 2 months, or after a huge amount of time, then we'll start struggling what exactly we have annotated. So that's definitely a good choice if we start keeping notes as per our understanding, because right now we are actually talking as well along with the annotations. We are also talking, so right now that makes a lot of sense. But when we try to look at these annotations after 3 months, 5 months, that might that might have some confusion. What was that? So it's always good to keep a pen and paper handy and keep on making the notes as per our understanding. Exactly. Awesome. Understood the method, how to treat, how to detect the outliers? Easy. In code, when we will implement it code, it's more than easy. We just need to plot a box plot. We just need to do the box plot, right? And that will give a figure somewhat like this, where these are the whiskers, okay? And there will be some dots like this. If there is any outlier, there will be some dots like this, okay? So this is this value, and this is this value, and these are the outliers. So we can simply plot a box plot like this. This is the y, and that's the column for which we want to detect the outliers. We can simply do a box plot, and we can extract anything beyond these whiskers. Correct? Candlesticks are different. Candlesticks are open, high, low, close. They are a little different than the box plots. They look similar, means the structure looks similar, but the values, how they are being calculated, are completely different. Okay? A very good and a very interesting project. Anyone in finance can do to detect the candlesticks from the given open, high, low, close data? Predict the candlesticks for a given data. That could be a possible project if you are in finance. As Q3 and bottom is Q1. Yes. And there is a median value. It will also give median. Okay. So we can simply use this and this as a benchmark. Anything beyond this is an outlier. That's how we can simply detect the outliers. Easy, everyone? Easy. That's how we detect the outliers. Okay. Now after the detection, what we need to do with them? Yes. Now we detected the outliers. Now what? What should we do with them? Remove, treatment, remove. Yes. And how will we treat them? Any idea how exactly we can treat them? Okay, again, there are possible methods. We can remove them easily. We can replace with the central tendencies, imputation. That's again a possible method. Or we can cap them. Capping is also a method to deal with the outliers. Capping means just replace with the benchmark, right? So replacing all the outliers beyond this value to this value itself. Yes, replacing with the boundary value. So either capping, let me mention now. Remove, right? Central tendency imputation, same. Okay. And third, capping. Now, these outliers will not be there in categories, right? The categorical variable will not have the outliers. Outliers are only possible in continuous variables. So we just need to detect them using these IQR values, and then we need to treat them with any of these three methods. Either we can remove them, we can replace them with the central tendency, and we can simply cap them. Okay, now the major question, to what column we actually need to deal with the outlier, because possibly we can have hundreds of columns, and out of those hundreds of columns there could be 50s, 70s, 60s of the columns that are continuous. So do we need to go one by one to every column and check the outliers and treat them? So the big question here is, where exactly we need to check for the outliers, right? Yes, makes sense. We understood the method, the concept of outlier, what is outlier, how do we detect them, and how do we treat them. These three things are clear. What are outliers? How do we detect? How do we treat them? This is clear. Capping means replacing with the benchmark value, replacing with the value where we treated them as an outlier. So if the outliers are at extreme higher end, we will replace them with this value. Okay. If they are at extreme lower end, we will replace with this value. So just replacing with the benchmark. That's the capping. Clear? Okay. Now the major question is when we should treat the outliers in the data. Okay. In order to answer that, we should treat the outliers first of all in the target variable. If it's a regression problem, we need to detect it in the target variable. Or when we actually start some modeling, we make hypothesis. Hypothesis means we make some assumptions as per our domain understanding, which factors are going to be most important in our analysis, right? So again, this is completely subjective, guys. There are not very hard and fast rules to to pick the hypothesis before we start a modeling. Definitely there are null hypothesis and alternative hypothesis predefined in case of statistical test, but right now this is not the statistical test. When we start a modeling, let's say we got a business problem, we got a data set. So before we start anything, we assume something. Okay, so in order to achieve these factors, these XYZ factors are going to be very important for us. So if there is something in those XYZ factors what we are giving special attention while our modeling, we need to detect, we need to treat the outliers in those special factors or in the target variable. Okay? Yes, guys? Make sense? Because possibly in most of the scenarios,
Now again, it is not always possible to have some domain understanding before we start the modeling, right? It's again not always possible that we have the domain understanding about the business and about the data set so that we can have a good hypothesis before we start the model. That's again not all the time scenario. So if we are going to work on the data strictly on the statistics because we have zero domain knowledge, then this rule doesn't it will not apply, right? So in such cases where we already have some domain understanding and we are assuming we are having some initial hypothesis about the factors, about the columns, that these XYZ columns are going to be very important in our further modeling. So in case if there is any outlier in those XYZ assumed columns, we need to deal with that or with the target variable what we have in our problem statement if it's continuous. So these are the two major use cases where we need to treat the outliers. Make sense? Yes, makes sense. If the domain knowledge is missing, we'll check for the outliers in all the columns. No, not necessary. Again, if we don't have that good domain understanding and if we have hundreds of columns, we can't do that. In that case, we can't do that. We just need to take care it in the target variable and we can use the predictors as it is. Because having outliers and predictors is actually not a big problem. Okay. And even if we have the scaling methods or there are different methods, there are lots of different things that we can apply on the data, scaling methods, feature engineering methods, they can take care of that. Understood? Yes guys, everyone? About the outliers, what are the outliers, when we need to detect them, and how we detect, how we treat, everything about the outliers. Clear? Capping. Yes, anyone wants to explain what is capping, guys? Anyone wants to say what is capping? Yes, replacing the outliers with the benchmark. What is the benchmark? Anyone? What is the benchmark, guys? Yes, anyone? What is benchmark? The boundaries on which we are detecting the outliers, not Q3 and Q1. Q1 minus 1.5. Yes, these values are the benchmark, guys. These values. This is the lower benchmark and this is the upper benchmark. Okay. This is the lower and this is the upper benchmark. If there is an outlier, in case of capping, we will replace that outlier with this value. Okay, perfect. All good with the outliers, everyone? Okay. Now, one last conceptual thing that what we can discuss today, and rest we can do the coding part of all these things tomorrow. That is the scaling methods. Okay, we can often do the scaling to our data. Now, what is the scaling? Scaling methods. Now, let me just explain the concept of the scaling thing. Technically, how we implement them, what are the formulas and other things, we'll see with the codes and other things. Suppose we have two columns, height and weight. Okay, so the scale of height and the scale of weight are going to be different, right? Yes, the scale of height and the scale of weights are going to be different. Yes, we cannot compare 43 kg with 43 centimeters. Yes. Now, with the help of scaling method, we transform the data in different scales into a standard scale, into a common scale. With the help of scaling methods, we transform the data in different scales into a standard common scale. Now, the standard scale is completely statistic, means this is not something we can understand, but yes, they will be transformed into some numerical range that will be same for all the possible scales. Okay, suppose we have height and weight. So ideally, height is in centimeters or feet, inches, something. Weight will be in kilograms, pounds, something. They have different scales. They will be transformed to a new statistical range, some numerical range, in which the values will be compared with the same number. Means the minimum and the maximum to that numerical range will be same for both the scales. That's what scaling means. Understood? Not actually the BMI. BMI is only specific in that height and weight value. Like statistically, there are lots of possibility. Not only height and weight is the possible case, but we can have lots of use cases in which data is having different scales, right? Yes. So if we want to place everything, if we want to plot all the columns we have in our data into a standard scale, we use scaling methods. We use scaling methods. Okay. Yes, guys. So scaling methods are basically the methods are some statistical steps, some formulas what we apply on our data to transform the columns that are in different scales into a standard numerical range. Means the minimum and the maximum for all the columns are going to be exactly same after doing the standard scaling or after doing the scaling. Okay. Yes, we can say that. Converting each and every column into 1 units. Normalization is also a kind of scaling. Yes, guys. Understood what is scaling method? We got the idea what exactly is scaling? Everyone? Scaling is basically transforming the columns, transforming the different variables that are in different scales into a standard numerical range where the minimum and the maximum for all the columns for all the variables are going to be exactly same. That's what scaling is. Clear? Before we code, we need to understand the concept logic, right? If you don't understand the logic, if you don't understand what exactly we are coding, so in that case also will struggle. So first, that's why we are understanding the method, the concept first, and then we'll proceed the code keeping that concept in mind. Yes, understood scaling, guys? Makes sense? The idea of scaling is clear. What exactly is scaling? No problem. The scaling is basically transforming the columns into a different scales. Okay. For example, let me try to pick some example. Let's say we have height and weight. We have height and weight. Yes. We have height and weight. I misspelled the height. It's HIGHT. Suppose we have height and weight. Now the minimum of height or the let's say average height we can consider 160 centimeter, the average height for a given data sample only, right? For suppose the average height for the given data sample is 160 centimeter, for example. And similarly, the average weight for a given data sample is 65 kilograms. Possible? Possible? Okay. Now see, the average values are completely different because they are in different scales. After scaling, the average values will be same. It could be anything, x, y, z, centimeter. Not, it won't be centimeter. It will be some another scale. This will be exactly same to another one, right? That's what scaling is doing. That's what scaling is doing. So now there will be some standard scale. Some standard scale what we will be having, and the average value for both the scales will be same in this standard scale. That's what scaling means. Yes, a new scale. We will create a new scale. Now understood? Okay. How will this help in modeling? It's gonna help in modeling because at the end of this scaling, we are going to have the entire data in a standard scale, in a common range. There will be a given range of the data. Yes. It won't be too much, like it will not be like one range is in decimals, one range is in thousands, another column is in hundreds. It won't be like this. So initializing the parameters will be more standard in that case, and we are going to get some, better results in that case. Does that say XYZ? Or I just mentioned it, so sorry, I just mentioned it hypothetically XYZ, some value. There will be some value. It could be anything, like depends on different series. This will be different values, but what I meant to say, the average will be same. Yes, it will be completely different. Anything else? How the scaling will happen? There are different methods. In case of standard scaling, the formula is different. In case of min-max scaling, the formula is different. In case of robust scaling, the formula is different, right? So first of all, before we proceed to the different scaling methods, how do we calculate this new scale? How do we transform the data into this new scale? Before we proceed that, we need to understand what is scaling, right? So understood what exactly is scaling, guys? Okay, perfect. Perfect. Both height and weight will be same. No, I'm not saying that will be same. If they'll become same, why do we want to scale it, guys? See, the comparison is not possible in height and weight because they have different ranges. Yes, the comparison is not possible here. Yes, we cannot compare 160 equals to 65. Yes, we cannot compare 160 equals to 65. Yes, guys, let's discuss this way. Let's understand this way. We cannot compare 160 centimeter with 65 kilograms, right? Yes, we cannot compare 160 centimeter with 65 kilograms because they have in different they have different scales. This makes sense, everyone? This makes sense, everyone? Okay. Now, for a given data set, if the average values, like the average height is 160 and the average weight is 65. For example, on a given sample data set, the average height is 160, average weight is 65. Make sense? Yes, does this make sense? This is the average. Okay. So this way, anything greater than this is the average 160 centimeter, anyone with 75 kilograms. So if we know the average, we know this person is heavier and bigger than this person. Yes, yes, but numerically 75 is smaller than 160. But numerically 75 is smaller than 160. How come 75 became heavier and bigger? Because they are in different scales. Now got the problem of different scales? Yes? Yes? Understood? Okay, now when they will be transformed to a standard scale, to a common scale, this will be transformed to some XYZ value, this will be transformed to some ABC value, and ABC will be greater than XYZ. So that comparison of these numbers in that common scale, we can get that ABC is the bigger and heavier person than XYZ. Now makes sense what is scaling? That's what the scaling is. And we have different methods of achieving these things. We have different ways to achieve this standard scale. Okay, now is it clear, everyone? Let me erase and let me then mention the methods. Is it so satisfying erasing all these things? Okay, now the methods. We have standard scaling, standard scaling. We have min-max scaling. And we have robust scaling. Okay, standard scaling, min-max scaling, and robust scaling. These are the three possible methods that we can apply in order to create a common scale of the data in different ranges. Okay, so that's what we will discuss. That's what we will discuss tomorrow. Apart from that, what's there in the bucket? Encoding categories. I should write it clearly. Encoding, again, the C looks like E. Categories. Now, what exactly is this encoding categories? Basically, how do we encode the categorical variables into some numeric variables? So let's say we have gender. The values looks like F, female, male, male, and so on. This got transformed to 0, 1, 1. Right? This got transformed to 0, 1, 1. That is a possible way to encode the categories. That is the possible way to encode the categories. And this method is called label encoder. Label encoder. Okay. This method is called label encoder, in which we simply assign some numerical label to every category and we transform it numerically. Easy? Easy. We simply assign some numerical label to a text category and we simply transform it numerically. Yes, guys? Everyone is clear with this form of encoding? Yes. It's not one hot, it's called label encoding. This is not one hot, this is actually label encoding. What is one hot encoding? Now let me explain what is one hot encoding. In one hot encoding, let's say we have the column account type. Okay, and we have three account types. Let's say T1. Let me write smaller. Let's say we have three types of account: T1, T2, T3. We have T1, T3, T1, T2, T3, T2, and T1. Right? Possible? This is the category we have in an account type. Okay. Now this will be transformed to three different columns. T1, T2, and T3. Okay, now T1 is going to have, this will be 1, 0, 0. This row will be 0, 0, 1. This row will be 1, 0, 0. This row will be 0, 1, 0. This will be 0, 0, 1. Right? This will be again 0, 1, 0. This will be 1, 0, 0. So that is also a possible way of encoding. That is also a possible way of encoding. Right? So these are two methods through which we can encode a category into numeric, right? Two possible methods through which we can encode a category to numeric. Understood, everyone? Clear? Perfect. Now we understood the entire concept of the things what we have to do before we start the modeling. Tomorrow we will implement the coding part of this. Though all the codes, all the functions are already with you, you can simply download the file, Pandas Basics. You can scroll it and you can try to have a look, try to understand. And you can definitely, scroll it to have some better understanding. Tomorrow we'll be implementing the code part. Yes, Walid, please go ahead, your question. Z scaling is, Z score is actually standard scaling, but the other scaling method, min-max and robust, is not Z score. The standard scaling, the very first method, is actually using the Z score formula, but the min-max and the robust is not using the Z score formula. Yeah, I will share this whiteboard. I would save it as day 3. Okay. Yeah, I saved it in day 3. And yes, that's all for the day. If we don't have any question, we can drop off, guys. If we have any question, please. Yes, guys, in case we have any questions, anything, please go ahead. No questions? All good? I hope this went smooth today. Yesterday we had lots of concerns about the way, about the pace, but I hope we were good today. Yes, guys, please, we are open for the questions. Let me upload whatever needs to be uploaded right away because I'll forget. I have this beautiful habit of forgetting the things. So let me just upload day 3 content today. So what I'll do, I'm uploading this whiteboard plus the code both. Oh, so I'm not alone. I'm not alone in that case, guys. I'm glad. Pandas basics. I'm updating both the things, though if there is any small changes we have made to the Pandas basics file, that's still, Dinner, not yet. I'll do dinner afterwards. What is agenda for tomorrow? We'll implement these coding plus if we get time, we'll start the feature engineering. That is PCA and LDA. For PCA and LDA, the first session, the first step will be to understand their mathematics, their concepts, what exactly is principal component analysis, what exactly is linear discriminant analysis, and then we will finish their coding. So finishing PC and LDA should be the agenda of this week, right? By the end of this week, we should be able to finish PCA and LDA. Let's keep this agenda for this finishing PCA and LDA the agenda for the week, and we are good with the pace. Okay, so we have two classes, that is tomorrow and day after tomorrow, to cover these concepts as well as what we did today. We are good with the pace, guys. We have enough time to finish PCA and LDA within this week. Supervised and unsupervised will take some time. After PC and LDA, we'll do supervised and unsupervised. Okay. From describe function, we can find no. In order to get the outliers, we need to plot the box plot. We need to do the box plot. PCA, that's basically the algorithms to select important data from the huge amount of raw data. PCA stands for principal component analysis and LDA stands for linear discriminant analysis. So the agenda for this week is to finish PCA, LDA with the concept and the coding, and we have enough time to cover that. We have two classes in which tomorrow's class we can utilize to do the codings of the things we did today, plus some introduction to the ML, what are the different branches and what are the steps involved. And the last day of this week we can cover PCA, LDA. Yes, guys, we can drop off. We are good to drop off. If there is any question, please. Otherwise, we are good to drop off, guys. Make sure you spend some time for the feedback, guys. The link will be popped up after you leave the session. Make sure you spend some time to give your valuable feedback. Okay, sure. The merge, just a sec. Good night, everyone. Good night, guys. Bye-bye. Take care. Stay safe. Merge. Here it is. Sure. That's the concat. Here we are actually doing the concat, and this is actually the first merge we did. Okay, you just need to go through with the self-learning videos available in LMS. I would say that's more than enough. If you can just you can just track up with the self-learning videos in LMS, that will be more than enough. And there are lots of videos available in YouTube. Also, Krish Nayak is a good channel. And there is one more stats, someone who used to sing. There is a channel in which they used to sing the statistical formulas. Stat fun, or there is something, some channel like that. StatQuest, yes, I'm so sorry. That StatQuest. They are brilliant. They are brilliant. StatQuest. Those guys are awesome. They explain everything with a very brilliant way. Good example and right way of explanation. StatQuest is also a very good YouTube channel if you want to refer. Okay, sure. Let me give you the presenter access so that you can share my screen. Okay, guys. I will give you the presenter access, but let's figure out some easier way in order to debug the errors. Everyone can install some remote desktop tool like AnyDesk or something so that we can do it more quicker. Okay, I am just making you the presenter so you can share your screen. Yes, you're
Hey,
good.
Professor, how are you? Can you hear me?
Yep, we can hear you.
Okay. So, I was having a little bit of trouble. Let me see. Like right here. You see how?
We can't see your screen yet. You need to share
Oh,
your
you can't see
desktop.
it? Oh, sorry. Where's the? I don't see that panel. So I go
And
to
in the WebEx itself and the WebEx window itself, you'll see share my desktop icon.
okay. Let's see. Okay, got it. Okay, can you see it now? Oh,
Yes, we can see, but that's the empty desktop what we can see right now. We cannot see
okay.
anything else. Then might be you need to stop the share. Okay, yeah, now we can see.
Okay, it's good now.
Yeah,
You still see it?
yes, we can see it.
Okay, great. So I was having trouble right here.
Mm-hmm. So
Um,
can you execute it? It's working.
no, I can execute it, but you see, it's not. The result is not the same as. It
Okay,
doesn't
the
come out the
result
same
is
as
not
yours.
same. That's because if you scroll it a little bit up, if you can scroll it a little bit up, see the column names in these two data frames are different. The first data frame is having the column name that is name, and the second is having name too. That's why the result is not different,
Mhm. Mhm.
right? That's the
Right.
cause. If we just rename the column name for the data frame 2 to name itself, it will give the same result. Yes, just replace this name 2 to name. Yeah, now just execute all the cells from here. Yeah, good.
Okay. Um, but like when you did this part right here with the merge, I think that was more
Mhm.
the issue. Because like when I looked at yours, it looked different than mine.
Let me check. Okay, so that's the outer join one, two on. Okay, subject ID looks perfect, looks perfect. Okay, so the possible difference could be the type of join only. You can change the types of joins and you will see the different results.
Mhm. Does it
Right?
change the outer?
That's the possible change. Secondly, the suffix can also be different. Right now it's section A and section B. If we remove the suffixes, it will by default give underscore X and underscore Y. If you remove it, the entire suffix, okay.
Oh,
No. Yeah, there is one extra closing bracket at the end. You can see there is. Okay, we don't need to give two brackets. There should be only one. Yes, remove from the end as well. Yeah, execute it. Yeah, and this says underscore X and underscore Y.
mm, okay. And then the other thing, right here wasn't like working. Oh,
Left
maybe
on
that's why I
subject ID.
misspelled it.
Subject ID 2. Something is wrong with subject ID 2. Right on 1, 2. Okay, 2 is having subject ID 2. Here, it's okay. Can you execute? Oh, okay, I got it. I got it. You just need to recreate 1 and 2. Just go to some above cells. Just scroll it a little bit above. Yeah, 2 cells above. No, 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 no. Just scroll it above. Yeah. Yes, execute here. This one. Execute this.
You keep the name one and
Yes.
name two, or just name.
Name. Actually, we need to make sure that subject ID 1 and subject ID 2 is there. Right?
Yeah.
Now execute the merge.
Okay.
Yeah.
Oh, okay. Oh, okay. So every time you have to do this, merge or concatenate, you have to add this.
Exactly, exactly. Because the way I placed the code is to explain the different use cases, and for the different use cases, we are trying to create different types of 1 and 2 data frames. That's why, in order
Mhm.
to get every possible execution, we need to re-execute 1 and 2.
Mhm. Okay, that makes sense. Um, yeah, because you only did the merge, because merge only is with outer, correct? So
Now,
you only did.
merge can take outer, inner, left, right, anything. The
Yeah,
concat can only take inner and outer.
right. Mhm. Okay. But in terms of like in the class, you only did the outer, or I mean, we did some other ones, I think, but I think that was the one I
There
had the
are
problem
outer,
with.
in case of merge, we can do outer, inner, left and right, everything. We saw all the results.
Mhm. Right.
Yeah.
Okay. I think that was. Oh, and then I had an issue right here when I was trying to create the new
What's the
column.
error? Could not convert string to float. Okay, it looks sales cock string dot replace this to this. Can you please execute it again? Sales dot just this cell 46.
Oh, cell 46.
Yeah.
Because like even cell 39 wasn't working for me. Oh,
And
sorry.
can you just show me the error statement? Could not convert string to float. This. Okay. Just above this 79, can you please execute the sales statement to see what the data looks like? Just above 79. Yeah. Sales. Okay. Cogs also looks good. String dot replace dollar. Why it's not working? Sales cogs dot string dot replace. Okay, got it. See, in the replace, the second attribute should be blank string. You have placed a comma in the second attribute. It should be a blank string. Yes. Now execute it. Worked. That's the warning. That's not a error. What we are seeing in this red background, that's the warning, and we are good.
Okay. Last thing. See right here, this
Short values
command
got
doesn't
an
work.
expected argument index. We just remove index equals to false from start values.
Okay.
Yeah, execute it.
Okay. But I thought we needed that for this command.
We need it in 2 CSV, not in sort values. Inside that was there inside 2 CSV.
Oh, that was over here.
Yeah.
Oh, okay. Thanks so much, Professor, for clearing that up. That was
Awesome.
a lot of great help. Thanks so much. Okay.
So yeah, you can pass me back the presenter access. Perfect. Thank you guys. Thank you everyone. Thank you all. Bye bye. Take care. See you. Stay safe. We can catch up tomorrow. Yeah. Anurag, sure. Yes, please.
Yeah. Hi, Ablas.
Hi.
Sorry to disturb you this time. I have pinged you. Again, I am going to ping you. I have a data which have a 2 million rows. So it's a time stage data.
Okay.
So what? So I'm just pasting the code right now. So I have to backfill the options like for what fill I have to do. So while trying to looping, so read the data, I'm using the chunk size, and then I append the data. That's working fine for me. But while doing the append, that's memory issues I'm facing that.
Okay,
So
in chunks it's working fine, but when we try to fill it in a single go, it's not working. That's the
issue. How we deal with that? So
is it giving memory error or memory allocation error sort of thing?
Yeah, it's memory allocation error getting.
Yeah, in that case we need to do it in chunks only. There is no other option, because actually if you try to understand the error statement, the program is actually constrained with the hardware, with the architecture. So it's unable to allocate the enough desired memory in our RAM. That's the concern. And in that case, the one possible solution is the chunk size, or that is the only thing. If it's about the execution time, we can use Dask and we can use the parallel processing. But if it is about the data size, we need to do the chunking only.
Just wait, I'll share my screen so you have a clearer.
Let me give you the presenter access in that case.
Okay.
Yes, you can share your screen.
Okay. Just let me know if you're able to see my screen.
Not yet. You just need to go to session info and there'll be a button to share your desktop.
Okay.
In WebEx,
okay.
You need to go to session info and then share my desktop.
Session info, where we have to go to the.
Okay, so if you see the left side of the WebEx, there will be 3 tabs: session info, HNS, non-PG data, whiteboard.
Correct. So I'm in the session info right now.
Okay, and in session info, you can see share my desktop.
Not getting it. Options there. Recording is there.
There's no share my desktop in session info. Share my desktop or share my screen, some sort of thing. There'll be a button like in the right in the middle.
Recording button, I'm getting it. Let me see that side. connected to the audio channel. Okay, so leave it. So I'm not sure where I have to fit the chunk size here. I can also give the condition for the chunk size here, or just I have to give the list. So I have a
Chunk size, actually, when we read the file, there is a chunk size. When we do the read CSV, there is a parameter chunk size where we can specify.
yeah in the pandas read CSV file.
Yes, and that will read the list of different data frames.
Session options. Not sure why it's not coming. Presenting option is there. Like option is there. A screen presentation is not sure. So I'm already just mm, this one. Chunk size, define the chunk size in the form of list actually.
Mm-hmm.
So suppose if I have to do the fill NA. So what is the challenges there? I have applied there with the in the form of list. Suppose in DF I'm just defining like this way. DF is equal to my list and the first chunks like 0 suppose.
Mm-hmm.
So what happening here in between the data is used. So might be the when chunk is divided those data. So there might be a suppose I'm just dividing data in the 1,000. But before that hidden, that is the when we're doing ffill, there is the top of that is a blank actually.
Okay,
So
okay.
that is the catch and issues I'm facing. Suppose when dividing the chunks, so we are not sure which one having a data and which one having a no data. So that's the catch.
Okay, got it, got it, got it, got it, got it. Now it will require some manual, some manual efforts using the program itself. Like there is null.any function in pandas that gives the places where missing values is there. Missing values are there.
Okay.
Is null.any. So we can actually extract the index, the row labels where the missing values are available. And in case that is at the first or the end, the starting or the end of the chunk is having missing, we can update the chunk size.
Okay, so like manually we have to go and check which
Not for everything. You can just write a code for it. You can actually write a loop for it, pick some random chunk size, see if the first and the last index is there in isnull.any. If it is, update the chunk size. Simple. We can simply
anyway, I will try it. Anyways, I will try to do that.
Yeah, let me try to make it more simplified. Just pick some random chunk size. Let's say there are some functions that can give some random value. Let's say I want to keep the chunk size between 1,000, somewhere close to 1,000, right? So you use a function to pick some random number between 950 to 1,050. It will pick some random number. I'll create that chunk. Now in that chunk, I'll use isnull.any function and I'll see if the first and the last value is missing or not. If it is, I'll just again pick some other random number and then I'll use some another chunk. And if this looks good, then only I'll go with the missing value treatment.
Okay, got it. You mean to say while defining the chunk size, we can create a loop where if the like whatever the chunk size we have given, if it is null, go to the next chunk size for that.
Exactly.
Okay, got it.
Yeah.
Apart from that, in any other ways we can do?
Any another way? One is this to iterate the chunk size, or if I don't actually.
Suppose I have to this code which I have given you DF. Suppose we have to loop in the column wise. Suppose we are just wanted to keep it for the 50,000 or 10,000 loop wise. So how can we do the loop in that fill functions?
Loop means, okay, so chunks are basically, if we create a chunk, they will create it with respect to the rows.
Correct.
Okay, while we do the ffill or backward fill, we can specify the axis, what forward or what backward we want to look for. If we specify axis 0, it will look the previous row. If we specify the axis 1, it will look the previous column.
Correct. So just I wanted to write in a for loop. Suppose for df like for I in the range particular range we have to give on, and I throw the rows. So that we can do in the fill functions. So it will.
Okay. Are we able to read the file in a single go, or we need to read it in chunks itself?
Sometimes we able to read it. Right now we have, like, this is the first time I'm studying the data. Normally we have a data, it's almost 100 millions. So that time it will work perfectly. It will read the data. So this is the first time the data size used. So in that case, I'm thinking if Pandas is able to read those zip files.
Yes, it will be able to read the zip files, but what I would suggest, create the chunk, the first maximum possible chunk what Pandas can read as per the system configuration, and try to loop that chunk, because if we have the data in a single object once, then we can play with the chunks, the further chunks. Let's suppose we have 100 million records, and the system capabilities are only to read 40 millions at a time, right? So we read 40 millions. Now in those 40 millions, we can create further chunks to do the backward fill and forward fill.
Okay.
And again, we can proceed to the next chunk, like the remaining 60 million, we can again read next 40 million, and then we can process whatever is required. Does this make sense?
Yeah. I think the best way which you have explained the previous is like better to keep a creating a chunks, and then you put the whatever the value is there, then missing, then process the first chunks, like first list of the chunks, then second, and process and then define the function for the all the list of the chunks.
Yeah.
Correct?
Yeah.
Okay. Thanks, Abhilash. Thanks so much.
Perfect. I hope we are good then, guys.
Yeah, good night.
Yeah. Awesome. Thank you, guys. Thank you, everyone. Bye-bye. Take care.
Thank you, sir, for this wonderful session, and thank you everyone for your participation. I request everyone to kindly fill the feedback survey form.